So I guess this all boils down to something called perfect squares and perfect cubes. Take a look at this. What is the difference between a perfect square and a square root? Perfect squares and square roots are related to each other. Look at this. How? Take a look at the number 25. This is called a perfect square. Why? Because it has two factors that are exactly the same. Exactly the same. That's what makes it perfect. There we go. So look, square root of 25, you know, breaks down doing the factor tree, 5 times 5. Take that wonderful pair out, one representative. Oh, there's nothing left under the radical sign. So your answer is, of course, just plain old 5. So a perfect square is a number that can be expressed as the product of two equal factors. Very, very important. Okay, here's another example, 16. A square root then is if you take this, one of the two equal factors of the number. So look, square root of 49, just choose 7, just like we did over here. So on we go. If we do that then, check this out. Look at perfect cubes. Perfect cubes and cube roots are related to each other as well. Because if you look at a number like 27, this in fact is a perfect cube. And it's formed by multiplying 3 factors together. 3 times 3 times 3 gives you 27. Symbol, of course, being cube root like that. But what's interesting here is some numbers are both perfect squares and perfect cubes. And I have to show you what that looks like. Look at 64. I love this number. Check this out. 64, if you break it down, is 8 times 8. There's your pair. Look at how that is so beautiful. It tells you if you're going to take that one representative out, look, nothing's left under the radical sign, meaning there's your perfect square. But if you take 64 again and break it down, you'll find out something cool. That's 4 times 4 times 4. So when we're looking at cube roots here, you can take that guy out and say, oh, there's your triplet. Your triplet then is 4, and what's left under the root sign? Nothing at all. So your answer can be 8 or 4. Some numbers can actually be perfect squares and perfect cubes. So let's take a look at all of the perfect squares and take a look at a sample of perfect cubes. Very, very simple. Look, I just do this. 1 squared, 2 squared, 3 squared, and I'm just going to list all my perfect squares and perfect cubes. And this is going to help me to remember when I'm doing my mixed to entires and my entires into mixed. They just are so nice to have that. 1 squared is 1. 2 squared, oh, my golf game. 4. 3 squared, German girl. 9. 4 squared, 16. You. 5 squared, I wish I had a nickel for every time I did this. 6 squared, 36, my waist size. Shut up, I'm trying to lose weight. 7 squared, 49 and holding. Ask your parents. 6 squared, 64, 1 year before retirement. German girl squared, 81, my age, Monday mornings. And 10 squared, 100, what I want to live to. Now look at the relationship over here when you're doing cubes now. 1 cubed is 1. 2 cubed is 2 times 2 times 2, which is 8. Still nothing there. 3 cubed is 27. 4 cubed is actually 64. And check a look. There's the relationship between the two. I'm just going to go up to 5 cubed because honestly, I've never done anything more than about 5 cubes. That's about 125. After that, just the numbers get too big and go into your factor tree and it's a lot easier to work with. Okay, so let's look at how this actually works and helps us. Take a look at this question. It says a floor mat for gymnastics is a square with an area of 196. It's 196 meters squared. So that tells you that you can actually start taking square roots here. So let's figure it out. Again, don't always go with 2s. Go with something a little bit bigger. So why don't we try 4? Okay, 196 divided by 4, I actually have it right here, works out to be 49. Okay, so this is 49. Break this down. This is 4. There is, guess what? 7 times 7. Check it out. Okay, so we can break this guy down to 2 times 2. This guy, just 7. This guy is 7. But we know to look for pairs. There's a pair here. The pair is 2. There's a pair here. We know it's 7. Look what's left under the radical. There's nothing left. So the radical doesn't even count. 2 times 7, that's 14. Check this out. The number 196 actually is a perfect square of 14 times 14. Isn't that cool? Right? Just by doing the factor tree and knowing a little bit of something about perfect squares. Look at this. Look at this guy. Here's a cubic box of 27,000 inches cubed. And you're probably going, oh my goodness, he's going to do a factor tree for that? Check out how easy this factor tree is going to be. I know that's 27 times 1,000. Huh? Yeah. And I know that 27 is 3 times 3 times 3. Way too easy. 1,000 is 10 times 10 times 10. So check this out. One representative from here, because we're talking, look at that, we're talking cubes. One representative from here is 3. One representative from here is 10. Guess what? This is 30. I bet you the cubed root of 27,000 is in fact 30. That's why we learn mixed radicals. That's why we learn perfect squares and perfect cubes.